Hello and good day everyone. Welcome back to another tutorial by Smart Bucats in fluid flow and properties of fluid flow. And today we are going to solve a question on the head loss due to friction, which says we are to calculate the head loss due to friction in a pipe, given that the pipe have a length of 750 meters and diameter of 40 millimeters. The liquid passing into the pipe have some properties. We are given the flow rate, the density, and the dynamic viscosity. We are then told to determine the head loss due to the friction. The pipe looks like something like this. Don't mind the drawing, it's just an illustration. Yes, we are told that the diameter that here is 40 millimeters and the length of the pipe altogether is 750 meters. So we are told that the liquid is passing through with flow rate, that's Q, of 66.7 times 10 to the power of negative 6 meter cube per second. Then the fluid passing through have a density of 1000 kilogram per meter cube, which shows us that it's water that is passing through the pipe. Then we are given another property, that is the dynamic viscosity is 1.14 times 10 to the power of negative 3 s per meter squared. We are then told to find the head loss due to friction. That is, head loss due to friction is unknown to us. That is what we are going to find. The formula for head loss due to friction for a flow in a pipe, we know that HF is equal to 4FL V squared over 2GD, whereby the F is the friction factor, and we can find it through several ways. It depends on the Reynolds number of the flow. It depends whether the flow is laminar, whether it's turbulent. So we have to find the Reynolds number first, then we will determine F, that is the friction factor. And L, we have it, which is 750 meters from the question, that's the length of the pipe. Then V, we have to find the V. We know that Q is equal to AV, so we can find V by saying V is equal to Q over A, because we have the Q, that's the flow rate from the question, and for the area, that's A, we can determine it from the diameter we are given. We know that area is equal to pi d square over 4, and we have the diameter, so the volume will now be V is equal to Q over pi d square over 4. So the 4 can cross and becomes 4 times Q. So therefore we will now have 4 times 66.7 times 10 to the power of negative 6, which is the flow rate we are given from the question, all over pi into 40 millimeters to meters will now be 0.04 square. Therefore the V, that's the velocity, will now be 0.053 meters per second, if you calculate it well in your calculator. So now for what we are looking for, we know that we will find F. We just found V. We have G, D, and everything from the head loss formula except the F. So for the F, we first have to find the Reynolds number, which we know it's equal to rho V D over mu. And the density we are given from the question, we found the V, we have the D, and we also have the mu, that's the dynamic viscosity from the question. So now Reynolds number will be 1000 kilogram per meter cube times the velocity 0.053 times the diameter of the pipe, that's 0.04, all over the dynamic viscosity we are given as 1.14 times 10 to the power of negative 3. Calculating this, you will see that the Reynolds number will be 1859.649. So since this is the Reynolds number, we know that for Reynolds number less than or equals to 2000, the flow is what? Flow is laminar. So for the friction factor, it have different formula, which is not what we are going to treat now. I'm just going to take the formula we are going to use. Friction factor of a flow in a pipe or a tube, that is if it's laminar. So the friction factor for laminar flow in a tube or a pipe is 16 over the Reynolds number. We now have 16 divided by 1859.649, which from my calculator gives me 8.460 times 10 to the power of -3. So now I can easily find the head loss, which I write the formula earlier to be head loss due to friction 4FLV squared over 2GD. I have everything now, therefore the head loss will now be 4 times F is 8.604 times 10 to the power of -3, then times the length, which happened to be 750 meters, then times V square. What's my V? 0.053 squared over 2 times the G, that's the acceleration due to gravity constant, then the diameter 0.04. Now the head loss, if you press the calculator well, you will see that it's equal to 0.0924 meters. This is the head loss due to friction in the pipe we are given. I hope you enjoyed this video. Have you subscribed to the YouTube channel? If no, kindly subscribe to this channel and press the bell icon so that you'll be notified when we upload our next video. In case of any question, kindly drop it in the comment section. We will always be there to answer it. See you in the next video.